Greenbackville has a mosquito issue. There's a ton of mosquitoes there, so we wanted to look into how the deterioration of the salt marsh in Greenbackville is affecting the population of mosquitoes.
And we also wanted to find a practical method for controlling the mosquito population, which we decided would be to use predators such as fish. This is just talking about the marsh deterioration. Essentially, the issue with the marsh is that there's impaired tidal flow, which is caused by several factors, but this leads to a reduction in nutrients in the marsh because there's less water coming in, which means that there's reduced vegetation because the plants need the nutrients. It means there's less dissolved oxygen in the marsh, so because the plants produce the oxygen, which means there's fewer predators such as fish because they rely on the oxygen to live. Finally, that leads to more mosquito larvae because they're not being predated at all.
And the tidal flow also impacts the temperature of the water. So when the tidal flows, when there are issues with it, the water is not being mixed around so much, and it's mostly stagnant, and which means that the sun heats it up a lot faster. So the water is getting really warm, and the tidal flow also makes the salinity of the waters change really quickly. So the waters can be, anywhere between fresh to salty to brackish, and it's changing a lot, and it's different in different ponds all over the marsh.
So a salt marsh is essentially, it's a coastal ecosystem. It's basically an area with a bunch of saltwater pools surrounded by low salt-tolerant grasses. There's usually a system of creeks that distributes tidewater throughout the marsh because marshes need, the habitat requires tidal flow for the species that live there. So marshes are very important. One big reason is that they prevent erosion because they act as a buffer between, the bay and dry land. So essentially, they help to, if there's a storm and there's a tidal surge, they can prevent flooding and erosion because the water is going to hit there first.
So the marshes also filter water as more water comes in, and it does that pretty much the same way that a fish filter would in a fish tank. In a fish tank, it's filled with gravel, but in the marsh, it uses peat, which is just matted up, decaying matter, mostly grasses, because that's what you find in the marsh. And so the water, comes into the marsh, and the peat traps sediment and pollutants that's in the water, and it breaks down the pollutants, it absorbs a lot of the water, and it helps filter. And the marsh is also a great habitat for lots of different wildlife. It's a great feeding ground, and it's an extremely productive ecosystem. It's actually more productive than a rainforest. Greenbackville, which is where we studied, was originally settled in the 1860s. This is just a little history. It was settled and used as a shucking town. They made a lot of money off of the oysters that they found in the bay, and the town quickly grew. They got lots of money. But then in the 1930s, their economy started declining, mostly due to the Great Depression. And in '33, they were hit with a huge hurricane. There was lots of flooding. The town lost a lot of money, but the biggest impact that the hurricane had was that it destroyed their railroad bridge to Ocean City, Maryland, and that's where they were getting most of their income from. That's where they were selling most of their oysters, so that had a huge impact on Greenbackville. And then on March 6, 1962, Greenbackville was hit with the Ash Wednesday storm, which was kind of the final blow. It destroyed Greenbackville and Franklin City. There were a lot of casualties, a lot of, it was a horrible storm, and Greenbackville has never really returned to what it used to be.
But of course, the marsh was left behind. So essentially, like I said, most of the issues that the marsh faces are caused by the impaired tidal flow. There are a few different reasons why that happens. The first one is mosquito ditches, which were dug in the early 1900s to prevent mosquitoes from developing because the larvae live in these pools, in these stagnant pools. The ditches were built to drain the marshes to get rid of this water, but it actually had an inverse effect because It's very unnatural for these long, we'll show you a picture in a minute, but they're essentially just these long straight lines that go right through the marsh, and they block the tide, which would normally refill the marsh with water, so it actually had a negative effect. The other thing that blocks the tidal flow is these oyster shells on the beach, which are left over from the shucking days. If you go to it's along the Chincoteague Bay, but the beach there is just lined with shells that sometimes are up to 6 feet tall. So unless there's like a huge storm, it's really difficult for the tide to get into the marsh, which it needs to, in order for the marsh to be healthy. So what happens is the water gets really hot. The fish and other predators can't live there, but the mosquito larvae are able to thrive. This process is called thermal pollution.
And also what happens is the water gets trapped in the marsh, and there's a huge reduction in the amount of nutrients in the water, so there's less vegetation, which limits shading, and so the water gets heated up faster, and that contributes to the thermal pollution.
So this just shows, if you can see these long lines here, these are all just mosquito ditches that you can see just cut right across the marsh. You can see it's pretty unnatural.
So thermal pollution is caused by lack of tidal flow. We're going to show you some pictures of the shells that are blocking the water, making it easier to heat up. And this is all caused by the shucking and Greenbackville.
Another cause of thermal pollution, which doesn't actually affect Greenbackville, as far as we know, but it's important to mention, is power plants often they'll take cold water from marsh environments, and they'll use it to cool down their machines, and then release hot water back into the ecosystem, which is really a disaster because it heats up the ecosystem, and it's bad for the environment. But yeah, it's probably not affecting Greenbackville. So this just shows you the beach. There's tons of shells, the marshes in the background, but it's very hard for the tide to get through. Here's one of the ditches from the ground level. You can see they were built to prevent stagnant water from existing, I guess, but you can see that it's just full of water that isn't going anywhere.
So this is one of the pools in the marsh, and it just shows how dense the mosquito larvae are. All of that black mass, that's just mosquito larvae sitting in the water.
Yeah, so initially we wanted to use fish, and, well, I mean, we use fish anyway, but we wanted to do an experiment in the marsh where we could track the rate of fish consumption of mosquito larvae. So we created this box down here, which is made of window screening, PVC pipes, and tape. And basically we were going to bring that to the marsh and put fish and larvae in it, and it would allow water to get in and out, but prevent fish and larvae from moving around. But we had to resort to a lab study because the marsh pools dry up so quickly, there's not a lot of oxygen, it's very hot, and it's just not an environment that fish can live in because of how unhealthy it is. So this is the YSI that CC talked about a little bit, but you can see that right here, it says 0% salt oxygen. So like this is just a pool that literally doesn't have any oxygen in it. So yeah, this is a full pool, and then this is a pool that's drying up. You can see the desiccation cracks in the ground. Yeah, and then here's a pool that's totally dried up. It's just an algal mat at this point. So it's not an environment that fish are able to live in because they drain away so quickly because new water isn't coming in from the tide.
So our lab study involved going into the marsh. We used a dip net to collect larvae and fish, and then we took the fish back to the lab. We separated them out and started feeding them the larvae that we caught. So we got a small mummichog, which we kept by himself, gave him 2 milliliters of larvae every day. And we intentionally overfed him to see what effect that would have, to see how much he would eat, just to study that. And then we also had another pair of mummichogs, which we put together, a male and a female, and we gave them both 3 milliliters of larvae a day.
We also had a naked goby, which we gave 1 milliliter larvae a day. Then we had a grouping of killifish, sheep's head minnows, and shrimp, which we had in one tank in these small separate enclosures. And we gave all those together 3 milliliters. We divided about So just for reference, 1 milliliter of larvae is about 111 individual larvae. And we actually don't have any data for the killifish because we started out with 10 or 2 at the end because they just ate each other. So. That's in order. So basically, to take their weights over time, you just fill a cup with water, put it on the scale, 0 it, and then add the fish. And it's pretty simple. We made a graph. And then for the data loggers, which we use to collect temperature data, we'll show you in a minute. You basically just activate them, then you place them in the pool, and then take them out a few weeks later, plug them in the computer.
So this is an example of how we separated our smaller fish. We just had a normal sized tank, and then we have those little floating tanks which we put in the water that kept the fish separate.
So this is the beach pond. This is one of the pool. This is the pool that was closest to the water. It was one of the only pools that we could consistently find fish in because it had enough oxygen, and it was one of the only pools that received consistent tidal flow because it was so close to the water. But you can see it's right next to the road. You can see tire tracks that are going through it, so it's definitely affected by people. So it's some cool guy collecting larvae in the field.
This is Dr. Cornell, who is our mentor. This is him just collecting larvae with a net, and you can see in the next picture how many larvae you get just from one scoop in the water. It's just a whole handful. And so we collected data on the dissolved oxygen using our YSI. We used we put the YSI in six different ponds to collect information, and you can see how much it varies, but all the numbers are very, very low.
Except for this one.
Except for
which
pond
is,
number 5.
we think there's some sort of error there. Very, very high.
And sites number 3 and 4 were actually part of the same pond, just different ends of it. So even in the same pond, the conditions are very, very different, which makes it a lot harder for fish to live there.
So this is just the YSI. You basically just place the sensor in the water, and it tells you all the information here. It's pretty cool. So these are the ponds this is basically a map of one part of the marsh. This is the beach pond that we showed you. And then these are the 2 ponds that we took temperature data from. This is the shaded pond, so that had bushes near it that gave it some shade, and then this is an exposed pond really close to it. Alright, this pond is exposed to sunlight, so they're very close to each other, but we wanted to see if we would get different temperature readings from them.
So this is a graph we made with our temperature information. The red line is the temperature of the exposed pond, the blue line is the temperature of the shaded pond, and you can see how the pond being in the shade doesn't make very much of a difference. They both got up to over 35 degrees Celsius, which is very, very hot. And then on the 25th and onwards, it started getting a little bit cooler, it started getting a little bit rainier, so that's what caused the temperature drop.
So the exposed pond actually got up to 39 degrees Celsius, which is about 102. It's about 102 Fahrenheit, which
I was
is
serious about that one.
that's about as hot as a hot tub, just for reference. So hard for fish to live there. That's what
You could always sing us a song. I heard you learned it.
Oh, yeah.
do the princess one. It's the eggplant song. Eggplant song. Oh, it's Shirli's song. Shirli's song.
I've never heard the eggplant song.
It's a song from our camp.
Peter, I'll be back on soon.
It would take a while.
It's time.
All right, here we go. So yes, we got up to 39 degrees Celsius. That's as hot as a hot tub. Obviously, fish are not going to be able to live in that environment. The temperature range from Mummichog, the maximum is around 35 degrees. Even the pool in the shade got above that at times. So it's going to be really hard for them to live in that environment.
So for Mummichogs, they don't exactly have a dissolved oxygen range because they've adapted to be able to live in anoxic conditions, which means there's no oxygen, for periods of time by gaping at the surface. So they're pretty resilient fish, but it's not too hot for them.
Yeah. And the shore shrimp, which is another species we studied, their temperature range is pretty similar. The same idea, they would have trouble living in this environment because of how hot it is, even though they're very resilient to temperature.
And they prefer waters that have a dissolved oxygen range of over 6 milligrams per liter, about. So they could barely survive in one of the pools that we tested.
Yeah, most of the pools were well under that. So this is the graph of the fish weights that we took over time. These three are Mummichogs up here. This is the smaller solitary one. It doesn't look like much, but he actually did gain consistent weight over time. This is the male Mummichog, who was the only fish that actually every single week gained weight. This Mummichog gained weight the first week and then lost, but had a net gain. This guy gained weight throughout. This is the female. You might notice the spike here. She actually got pregnant and laid eggs. So that's not a big weight, but she had a net gain, net weight gain. So that was good.
And then at the bottom there is their smaller fish. And the naked goby and the sheep's head minnows both lost weight consistently. But the shore shrimp and the younger Mummichog had a net weight gain.
So yeah, essentially the Mummichogs gained weight consistently. They ate the larvae very voraciously. So the shrimp gained weight as well, but they did it very slowly. And the issue with the shrimp is that they need higher dissolved oxygen levels than were available in the marsh because they were very low. The goby lost weight over time, like we said. We think this is probably due to the fact that he's not a true marsh inhabitant. They usually live in bay areas, so the food source that we were giving him, which was larvae, would not be found in the bay. The sheep's head minnows also lost weight, probably because they usually eat vegetation or detritus, which is dead stuff, so they probably wouldn't eat larvae.
But overall, during our study, we observed that all of the fish preferred the live larvae to the dead larvae.
Yes, so like I said, Mummichogs, we think they're the best in terms of our purposes as a way to control the mosquito population. They can live in the marsh, they can survive in very low oxygen, very high temperatures, they eat larvae. The goby and the sheep's head would not be good options. The goby is in the wrong habitat and the sheep's head is eating the wrong food source.
The habitat in the marsh is not suitable for fish right now because of, well, there's the whole issue with the pools evaporating so quickly and the tidal flow problems. There's not too much rain in the summer to replenish the water, and there's also the very low dissolved oxygen, the very high water temperatures. But all of these conditions benefit the mosquitoes because they can survive in these hot waters. And they only need to be in the water for several days before they mature into full-grown mosquitoes. So, while fish need a constant water source.
So if the water dries up, the mosquitoes can still survive there. We also observed when we were walking through the marsh one day, it was a cooler day, and the water actually was pretty cool. We were looking around for larvae, and we couldn't really find any until we got to one area of the marsh, which was very, very warm, and they were all over the place. So we definitely observed a warm water preference from the mosquitoes, so the thermal pollution and all the issues of the marsh, how hot it is, are benefiting the mosquito population. So if we had more time, I think we would test fish at different temperatures, salinities, and acidities, just to get a better idea of how they live in different conditions and how it affects their diet.
We would also need to find out how to stop the evaporation issue, help the pools stay full of water. And this is all part of the longer term goal to eventually restore the marsh to health, and with that comes fixing the mosquito issue.
So yeah, we just wanted to say thanks to Dr. Sean Clow from Shippensburg University. He fell in the marsh here. Thanks to the MSC, and thanks to Blair for driving us to the marsh.